A few years ago, I built the Agostini Millennium Falcon, but let's say there were some shortcomings, like the lights on the cockpit control panel. This year at Christmas, I had the idea of modifying the control panel, but I wondered how flashing LEDs actually work, so I took one apart. Strangely, I noticed that the wires connecting the LED to the electronics that make it flash were not two, but actually four. I dismantled the entire cockpit again, especially the control panel where a series of lights are printed. And buttons, of course. I would like to replace those printed designs with micro LEDs. Some LEDs will be flashing, others will stay on steadily. I disassembled the Christmas light circuit board, replaced the battery holder with one of mine, then soldered the wires for my battery holder so I could test it. The micro LEDs have a supply voltage of 3 volts, while the battery holder I have provides 4.5 volts. I proceeded by soldering the LED in parallel with the existing LED, and as you can see, it works perfectly. The drill bits I have available range from 1 micron to 1 millimeter. I start preparing the console with the holes that will house the micro LEDs. These are the holes just finished. I feel like making a lot of them since they will all be lights that turn on in the darkness of the cockpit. I insert the first LEDs, which will be the white ones that stay constantly on. As you can see, the LED is represented by a sort of arrow and a bar. The arrow is the positive pole and the bar is the negative pole. As you can see, I'm arranging the LEDs, one facing one direction and the next facing the opposite direction. Then each side of the LEDs is joined together, as you can see. At this point, we'll have the positive pole on one side and the negative pole on the other. The negative pole is this other wire that will go to the battery pack. Now, this diagram repeats in blocks of 4 LEDs, so to make a long chain of LEDs, even 200 LEDs, however many we want, we still have to prepare them 4 at a time. At this point, we move from theory to practice. I position the LEDs according to the diagram, placing the positive and negative in the correct positions. I start twisting the LEDs together and solder them to each other according to the diagram I made. So now we have the 4 LEDs connected one to another. After connecting the 4 LEDs in cascade, as shown in the diagram, I add wires that will later connect to the flashing light circuit board I dismantled earlier. This is the circuit board for the flashing lights. As you can see, there's all the electronics with an integrated circuit that makes these blinking lights operate with a sort of independence. Now I test it, and as you can see, it works perfectly. I reproduce what I did with the mini LEDs using the micro LEDs, which will be the illuminated buttons inside the control panel. It should work the same way, but while I'm doing this, I get the idea to use a variable color LED that I'll use as the screen in the center of the control panel. Unfortunately, the LED is round, so with my Dremel, I adapt it to the hole I prepared, test it in place, extend the wires while marking the positive pole, and glue it in with super glue. I start setting up the fixed micro LEDs in the holes I prepared in the console. These micro LEDs will remain steady. Because the screen LED is a variable color LED, but it still needs a constant power supply, not the intermittent one of the flashing push-button lights that I had planned for the rest of the console. Once positioned, I glue them. I make sure that all the positive poles of the LEDs are connected together, and the negative poles as well, then I solder them. I do a quick direct test with the batteries to see if everything works, and it does. I continue adding new fixed LEDs. I start with the flashing lights, reproducing the usual 4 LED wiring scheme once they're soldered together. Because before mounting them in the console, I always recommend checking that everything works properly. I prepare a temporary solder connection to the flashing circuit board. Everything works, so I can proceed with placing the LEDs into the dashboard holes and securing them with cyanoacrylate glue. Once the LEDs are in place, I refine the drilled holes with the utility knife, also using the drill bit to bevel the hole entrance. This is a preview of how the flashing LEDs will look. But how do I tell which side of the LED is positive and which is negative? Simple. Just follow the positive and negative poles of the battery. I connect the positive wire from the battery holder to the positive of the LED. I continue the positive side connection with a spliced piece of electrical wire that I'll use to interrupt the circuit. At this point, I connect the negative pole to a piece of white wire. These two pieces of electrical wire, one white and one red, act as a switch. If I connect them together, as you can see, the LED lights up. So when the LED lights up, it means the circuit is closed and there is electrical continuity from one point to another that you want to test. I recommend using fairly rigid electrical wire, and here's how the console looks. Subscribe if you want to stay updated.